Do you see the, right now, do you see the unit test in front of you?
Yes.
I just want to make sure that you guys see where it says unit test. What we're going to do is we're just going to be working on these problems, and I'll be typing them into the Khan Academy, and I'm just going to go through a whole unit test, and hopefully this will help you guys. I mean, some of the questions aren't going to be exact same as yours, but they should be similar. Okay. Now, first thing, this right here is considered to be a complex number. So, Allie, what I'm going to ask you and Josh and Angel, can you hear me yet? All right, so Allie, an A plus bi, one of these is real and one of these is imaginary. Which one do you think is real? The A or the B?
The A.
Right, right. So right now, these are the A values right here. All right, and then these are going to be the B values. So what do we do with their A values, the B values? We're just adding them together. So all we got to do is just take negative 21, negative 30, add them together, and we get negative 51. Then we just take our B values. How many B values do I have right here? 65. I have 65i. I have 12i. And what does it ask us to do? Just simply add them together for a total of 77. Now, it's going to be very important when you guys are typing into the Khan Academy that you put the A value first, the B value second. Josh, how do you think I'm going to write my final answer right here?
Negative 51 plus 77i.
That's it. Negative 51 plus 77i. That's all it's left. Negative 51 plus 77. Always put the real numbers up front and the imaginary numbers. All right, now this one's going to take a little bit more time. So if you would, go ahead and write down on your paper 6x squared plus 5x plus 4. And I'm going to underneath it put ax squared plus bx plus c equals 0. So we have to be able to identify the a value, b value, and the c value. The a value is going to be 6. Our b value is going to be 5. Our c value is going to be, and we're going to be using the quadratic formula for this. So just remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, Josh, do you remember what we do first? When we're doing?
No, I don't remember.
That's right. So right now, does anybody remember what we call b squared minus 4ac? It has a specific name. Starts with the D. Then an I. Then an S. Somebody shouted in.
Discriminant.
Yeah, the discriminant. There we go. All right, so that's the discriminant. That's the very first thing we always find. Okay, so when I find b squared minus 4ac, I'm going to put open parentheses because they matter. I know it's been a while since you heard me say that. All right, what number am I plugging in for b, Josh?
I'll
give you a hint. This, it is.
15.
Just 5.
Oh, 5, my bad.
You got it. All right, now I think you got it now. What you got? What's the a value?
A value is 6.
Perfect. All right. So I'm kind of just checking to see if you can see things on your end. That's all. All right. Our c value is 4. So what we have to do is we do 5 squared, which is 25. All right. Minus. Now we have 4 times 4, which is 16. We have to do 16 times 6. All right, which gets us 96. We're going to do 25 minus 96. Now this is not good because 25 minus 96 gets us negative 71. So we have a negative number that goes inside of our discriminant right here. So here's what we're going to do. We're going to plug numbers in. That says negative b. So we're going to plug in a negative. We're going to plug in a 5 for our b value. We're going to do plus or minus the square root of negative 71 all over 2 times my a value. Now 2 times 6 is 12. So I'm just going to put the number 12. Here's the problem. This is not a real number. So we have to know how to simplify the square root of negative 71. Okay? So the square root of negative 71, here's what happens. Does anybody remember what the square root of negative 1 actually equals? It's an imaginary number called I. So if I say the square root of negative 1 times the square root of 71, that's how you can break this down. So basically, what does this ultimately become? It becomes the square root of 71 times the letter I. And that's why when you're breaking everything down, what do we have to replace this with? We have to replace it with the square root of 71 times the letter I all over 12. Now you probably take this and probably find the correct answer from this. So how do we break this down? What's our denominator? We've got a 12 right here in our denominator, so our final answer is going to be negative 5, 12, plus or minus square root of 71 over 12 times I. All right, so let's take a look at our answer choices up here. See here, we got negative 5 over 12, plus or minus. I think B is going to be our best. Yeah, B is definitely our best answer for this particular case. All right, so what's the first thing I want you to do? First thing I want you to do is identify what? A, B, and C. What do all quadratic equations before you use the quadratic formula? By the way, this is the quadratic formula. I'll write it up here while you're taking notes. Quadratic formula. First thing you find in your quadratic formula is you find your discriminant. And this is what I found our discriminant to be. B squared minus 4AC. Any questions while we're doing this? Any place where you're like, wait a second, I have no idea what you did when we were going through the problem? Is everybody, anything specific? This is where you guys need to ask some questions, and I need to do my best to try to help you.
I'm good.
Allie, you good?
I'm good.
Okay. All right, so we're going to go ahead and select B. Oh, okay, here's a good one. In your journal, you should have this, but I'm going to go ahead and rewrite it, okay? We know I, just by itself, is equal to this concept called the square root of negative 1. So I to the power of 1 is just the letter I. I squared is equal to, from your journal? I squared is negative 1. I cubed becomes negative I. I to the power of 4 becomes the number 1. Now these should repeat. So like I to the 5th would still be I. I to the 6th would be negative 1. I to the 7 would be negative I. I to the 8 would be 1. Now ours is pretty easy. We're just going to say our answer is going to be negative I because it only says I to the power of 7. So this is a pretty easy pattern to figure out. Understand it always goes in groups of 4. So anything in this row will just be I. Anything in this row will equal negative 1. Anything in this row will equal negative I. And last but not least, anything down here will equal 1. But what if we had a more difficult one? I don't like I to the power of 7. What if we had like I to the power of 39? What would you do to be able to find like what is I to the power of 39 without having to rewrite it over and over and over until you got to a 39? I want you to understand everything goes in groups of 4. All right, this is a pattern of 4. So what you do is you do 39 divided by 4. So I'm gonna do 39 divided by 4. So just you can go to your calculator if you want to. Just do 39 divided by 4, just like that. What's our remainder? What's our decimal remainder? 0.75. So our decimal this was a 9.75. 0.75 is important. In this row, the remainder will always equal 0 because these are all factors of 4. The first row, the remainder will always equal a quarter. So anything that has a quarter at the end, you'll know it's in the first row. This remainder will always equal a half. And this remainder will always equal 0.75. So if I said, what is I to the power of 39? What would you guys say the answer is? I, -1, -I, or 1? What do you think? What do you think this ultimately becomes?
-I.
-I, you're right. Very good. All right, because it has a remainder of 0.75, ours had a remainder of 0.75, so we would choose -I. But for us, check this out. Even if you did 7, check this out. 7 divided by 4. What is 7 divided by 4? 1.75. It still has the same remainder, which allows us to easily be able to say our answer for this one is going to be -I. So I to the power of 7 is -I. Okay. All right, so not much you can do as far as graphing, like on your paper, but I want you to understand. See the RE? You guys know what RE stands for?
Remainder. Huh?
Ah, good question. I mean, good response. RE is actually our real numbers, and IM stands for our imaginary numbers. All right, so what I want you to understand, any of your A values you're going to plot here. These are your GI values. All right, so I'm just going to plot a point right here, and we're going to interpret it, okay? Now, you don't have to do this on your paper. Just kind of watch the screen. Hopefully you can see it okay. Now, where is this point at on the real number line? That's at a 7. So this point would be at 7. And what's it on the imaginary? Also 7. So we call this 7 plus 7i. This point right here we would call 4 plus 2i. This point right here, hopefully you guys can see it okay on your end. I don't know what resolution you have. I can see it clearly on my end, but I don't know if you guys can see it on your end. But this is -6 minus 2i. So I'm going to throw a random point and see if you guys can come up with the answer, right? What do you guys think? I don't know if you guys can see it from your end, but right about there. Can you see it on your end, Josh or Allie?
Yeah, I can see it.
All right. So how would I label this point? Right there.
-3 minus 9i.
Close. -3, but we're going to put
Okay.
plus 9i because we're up here and this is positive. Okay.
Oh yeah.
Does that make sense?
Yeah.
All right. So -3 minus 9i, we would have to go way down, right about there. I'm guessing right about there. Okay. All right. So I'm going to go ahead and take this off the screen right here and take a look. Now, what does that say? It just says plot 8i. Just 8i. Is there any real? You see any real numbers there?
No.
No. So basically, it's asking us to plot this. It's asking us to plot 0 plus 8i. And 0 plus 8i is right there. So 0 on the real numbers and 8i in the imaginary numbers. So that's where I'm going to put my point, right there. Okay? That makes sense to everybody? Good?
Yeah, that makes sense.
All right, cool. All right. Now, this one asks, what type of number is this? All right. So we're going to go over, if you got, let's say, for example, what if you just had the number 4? We're going to talk about that. But what if you had the number 3i? All right. And then what if you had the number 52i plus 7.5. So we're gonna classify these numbers. So the number 4 can be rewritten as 4, or you could call it 4 plus 0i. So the number 4 by itself is just called a real number. But if I say plus 0i, that's referred to as a complex number. So the number 4, you could classify it as a real number, but you could also classify it as a complex number, because technically you could just add 0i and call it complex. So if they said what type of number is, and they just gave you a number, make sure you choose what? Real and complex for your answer. So far, so good? So if they just give you a constant, like the number 4, or 5, or 10, or -2, what do you choose? Real and complex. But what if they say they gave you just the 3i? Well, 3i is a pure imaginary number, but you could also write 3i as 0 plus 3i. So you could write it as a complex number. So 3i, if they gave us what type of number is 3i, we would call it imaginary, but we could also call it complex. What does a complex number have to have? It's got to have a plus bi. If it's just a plus bi, then there's only one answer. So this right here, this is the b value, this is the a value. So this is the only one that classifies to be just completely complex, because a complex number has to have an imaginary number and a real number. Technically, a better way of writing this would be 7.5 plus 52i. That's how you would want to write it. You always want to write it in the form of a plus bi. So when it says choose all answers that apply, if you got the number 4, what are you going to choose? Real and complex. If you get 3i, what are you going to choose? Imaginary and complex. But if you get literally just a complex number, then you just choose complex, and that's it. I know I said a lot, so question. Any question of what I did with the green or the red? Does that not make sense, or confusing? I can't see your eyes, so I don't know. When I look into your eyes, I can tell when you guys are, understanding or not understanding. Let's see here. Zane, can you hear me okay?
Yes, sir.
All right, Angel, can you hear me? Well, Allie, you still there?
Yeah, I'm here.
All right, Josh, you there?
Yeah, I'm still here.
All right, make sure. All right, okay. I'm just going to go on to the next question, since you guys don't have any questions so far. All right, so here we go. It says, what are the real and imaginary parts of Z? So look at this question. Zane, can you read that for me? Can you see it okay on your end?
Yeah, Z equals 32 plus 41.9i.
Perfect, okay. So Josh, which do you think is the real and which is the imaginary? What would you name it?
The real is 32 and the imaginary is 41.9.
Yeah, okay, so let's take a look at these. Which answer would you think would be the best choice?
B.
You know what? I agree to a certain extent. You see the 41.9i, you can actually just call the 41.9 the I part. That's the imaginary part. So I think A is going to be, we'll find out. I could be wrong, but I think, so if you guys get a question like this, we'll find out what they want. But I feel like my best answer would be 32 is the real part, and the 41.9 is the imaginary part of it. Because because it's 41.9i. We'll see if I'm right or wrong. We'll see. You know what? If it's not A, it's definitely B, Josh. I agree. Okay. All right. So here's a quick thing, quick lesson. All right. I like your answer too, Josh. I mean, 41.9i is the imaginary portion, but we're just going to call the part in front of the I the imaginary part. If that makes any sense. All right. So 32 is the real part. 41.9 is the imaginary part, but the complex number is 32 plus 41.9i. I'm glad we went over that one. Oh, cool. Hey, down, guys, right here, put plus or minus the square root of negative 1. We'll show you guys how to simplify this radical. And then we're going to do a more complicated one. This one's a little too easy. Hopefully you guys get an easy one, but you might have a more complicated one. So we're going to put plus or minus the square root of negative 81. And we're going to break this down into its parts. Okay, we're going to break it down into the square root of negative 1 times the square root of 81. So, Allie, which one do you want to tackle? The square root of negative 1 or the square root of 81? Which one do you want? She's like, I want neither. Don't give me anything. Stop asking questions. Josh, you want to take?
What?
You want the square root of negative 1 or the square root of 81? Which one do you want?
81.
All right, what's the square root of 81?
9.
I don't know.
Boom, you got it. I heard you, Allie. 9. The square root of 81 is 9. Does anybody remember the special value of the square root of negative 1?
I.
Yeah, it's I. So together, I times 9 becomes 9i. So when you guys break this down, ultimately my final answer is going to be plus or minus 9i. And I'm done. That make sense?
Yeah, that makes sense.
That's good. All right, now let's do a little more complicated one. What if they gave you, I'm going to go down a little bit further so it get a nice, what if it said the square root of, say, like negative 20? What do you guys think ultimately that would, what's the first step? What do you guys think that would become?
Square rooting it?
Yeah, so we can't just put that in the number in the square root because that's not a perfect square. But right now, would you guys still agree that still the square root of negative 1 times the square root of 20? Like you could break it down.
Yes.
So
Yes.
what's the square root of negative 1 always become?
I.
Good. Now, this is where the square root of 20, we have to break it down just a little bit. Anybody can speak up, just any factors of 20. What two numbers multiply together to equal 20?
2 and 10.
2 and 10, good, 2 and 10. All right, what about two numbers that multiply together to equal 10?
2 and 5.
Good, 2 and 5. Now, square roots look for groups of 2. Everybody see these pair of 2s right here? Can you see that on your screen?
Mhm.
All right, so ultimately that becomes 2 radical 5. So what is the square root of 20 simplified become? The square root of 20 simplified becomes 2 radical 5. So how would I write my final answer for this? If I said, what's plus or minus this? This would become plus or minus 2 radical 5, and then put the little letter I next to it. So if you don't have a perfect square, what do you have to do? You have to simplify the radical. So you have to simplify the radical. Now that's a cool. Simplify the radical. So what do radicals look for? Groups of 2. Now why was ours an easy one? Because what does 81 break down to? 81, what are the two factors of 81? It breaks down to a 9 and a 9. You're done. All right, so this one becomes pretty easy. We're just going to put plus or minus 9i. Okay. What's it asking us to do on this? Just multiply. Give you guys a chance to write that down. What property are we going to use to multiply? I'll kind of highlight it, kind of give you a hint. If I say we're taking this and we are multiplying, what property do we call that again? It's been a while. Don't all say it at once. All right, distributive property. All right. Angel, if you can hear me, what's the product of 3i times 15? All right, Zane, how about you?
I don't know.
Not sure? All right. All right, so we have 3 times 15. That gets us a total of 45i. Now, this is where it gets a little tricky. We have 3i times 2i. 3 times 2 gives us a total of 6. But I times I gets us what's called I squared. Now, this is very, very, very important. You should have this in your journals. Anytime you guys see I squared, I want you to think of -1. When I say I squared, you say -1. I squared.
-1.
Good job. All right, so what I want you to do is take this 45i, keep that the same, but watch what I'm going to do. Instead of this being I squared, I'm going to make it a -1. We have 6 times -1. So 6 times -1 is -6. Now, I rewrote something a little bit differently. Instead of writing 45i minus 6, how did I write it? I wrote it as -6 plus 45i. Now, why is that important that we actually write it this way? What do you guys, how would
Because
you?
you have to have the A plus BI formula.
Perfect, because it's got to be an A plus BI. So that's why I'm going to have to, when I type it in, I got to type it in -6 plus 45i. Even if I wrote it as 45i minus 6, they would count me wrong because they told me specifically it needs to be an A plus BI. Okay? Now, we're going to do this last problem a couple of different ways. So while you guys are writing this problem down, -2 minus 3i times 5, -5 minus 2i, we're going to write it down 2 different ways. And you guys we can figure out like how you guys like to multiply. So, well, this is the more traditional way. We're going to do the FOIL method doing this way. Now, another way that I like, and I'm going to change this up to a nice box. It's kind of like the array method. See if you guys like this way, because either way will work. I want you to create a box. We're going to be multiplying using arrays. So we're going to put, I'll put this in red. We have -3i. And then we have -5 minus 2i. All right, so I got it set up. So anybody need more time setting theirs up?
No.
We all good? All right. By your silence, I'm assuming that you're good. So we'll do it the more traditional way that I was taught a long time ago. We'll take this -2 and we will distribute it to the -5, and we'll take the -2 and distribute it to the -2. So -2 times -5 is a total of 10. And -2 times a -2i is a positive 4i, because a negative times a negative is positive. We're doing the FOIL method, then we do this right here, inside. All right, I'll do this in red. We have -3i times -5, which is a positive 15i. And -3i times a -2i is a positive 6i squared. Uh-oh, I just said I squared. When I say I squared, what do you guys say?
-1.
That's right, thank you, Zane. I squared equals -1. So what I'm going to do right here, I'm going to plug in a -1 right in there. So here's what we have now. We have a 10. 4i plus 15i is a total of 19i. And then we have plus 6 times -1. So 10 plus 19i minus 6. And 10 minus 6 is 4. So I would type in 4 plus 19i into the Khan Academy. So that's just using the FOIL method. First the first products, the outside products, the inside products, and the last products. But another way of doing it might be a little bit easier for y'all. Kind of like this way too. All right. What's -2 times -5? That product is 10.
10.
-2 times -2i, total of 4i. -3i times -5 is a total of 15i. -3i times -2i is 6i squared. But you guys know that that actually means 6 times -1. So ultimately, I'm going to leave it as a what? -6. Why do I like this way? Because what can you simply look at? You can see your numbers that you can add together. How many i's do you guys see? A total of what? Total of 19 i's. If you add them together. And then what do we have left over here? We've got a what? A 10 minus a 6. All right, 10 minus 6 is 4. So what I want you guys to see, whether or not you do it using the array method or whether or not you're doing the FOIL method, what do you still get? 4 plus 19i. This might be an easier method if you don't like the FOIL method. All right, so just remember the FOIL method. I'll kind of do a quick little review of the FOIL method if you guys want, or if you guys are good, I won't do it. I don't want to waste your time. We have the first products, the outside products, the inner products, and the last. Allie, which method do you like? You like the FOIL method way or do you like the box way? Which one do you prefer?
I like the box better.
Like the box? What about you, Zane? Which one do you like?
I like the FOIL method.
Like the FOIL method better? Josh, what about you?
I like the box.
Box? Okay. Anybody else want to chime in? I don't know who else is on here. I gotta go back and check. Guess nobody else wants to chime in. All right. Okay. That's all right. All right. Well, we'll go ahead and we're just gonna type this in, and then I'll answer any of your questions that you guys have. Okay. 4 plus 19i.
Okay.
The main thing, how about anything that you guys have been working on that I'm not sure how many people, this is going to be what's going to be due, like not this week, but by the end of next week. This is the other assignment, so we can do another one of these later. Any specific questions that you guys have that you wanted me to work on, anything that's on your screen and we can talk about it, or any problems that you've been stuck on?
No.
No, I'm good.
You're good, Josh?
I'm good.
I'm good.
All right, so do you guys think for just getting done with all the complex number stuff, was this okay? I mean, was this a good way of meeting together, or?
Yeah, I kind of like this.
Okay. Because what we're going to do, hold on. You guys see, I'm going to go to different assignments so you guys can see. We have simplifying common monomials, simplifying advanced, these right here. What I'd like to do is make sure everybody kind of gets through the complex number unit test and get that complete. See, right now I have 1 of 8, this one class completed. Okay. Once you guys, I'm going to give you guys a few days to get through the unit test, then I'll set up another meeting. And we can start working on learning how to simplify rational expressions together, where we just start doing example problems, okay?
Okay.
That sound good?
Sounds
Yeah,
good.
sounds good.
All right. Now listen, if you guys want, we don't have to be on here for forever, you know what I'm saying? Like, we don't have to be on here for a whole hour. I schedule it for an hour. But if you guys needed some individual help, where like you just were stuck on a problem, if you send me a remind, I can see it, and maybe we can schedule a time to just work on that individual problem. And maybe only takes 5 minutes, but we can both hook into Zoom. You can see my screen. You can tell me what your problem says, and I can work with you on it. Is that okay?
Yeah, it sounds good.
All right. So here's what I want you guys to do. Just kind of keep in contact with me. I will schedule, whenever I schedule a meeting, I will send it like for like a whole class meeting where you guys are kind of have an opportunity to kind of see me do a few problems and start a new topic. Like I'll do the more advanced one. Let's see here. That's easy. This is a bit more advanced. All right, where you like you watch me like factor everything. Then we'll kind of do that together, and then I can work with you individually. All right. Is that good enough for today? You guys have any, or do you guys have any other questions?
I have no questions.
Yeah, me, that's pretty good for today.
All right. All right. Well, hey, thanks for coming, and I'll send out a new meeting when you guys have 2 days to get rid of your get done with all of your complex numbers, okay? And then we'll set up a new meeting for simplifying rational expressions.
Okay, sounds good.
All right, y'all have a good
Is
day.
there any update on when school's gonna be back up?
That part I don't know. That's more of the that's going to be kind of mandated by the state more than it is by. So I'm not sure when we're going to be able to see each other face to face. But until then, hopefully this will be a way where you can ask questions and we can work on things together. Okay.
Yeah.
Okay.
Thank you.
All right. Y'all have a good day.
Bye.
Bye.